So, thank you, Steve. Nancy asked if I could kind of provide a little overview based on everything that we've heard today, where things are going. This is initially I thought, yep, that won't be too bad of a job. Except when I started this, I started thinking about it. And just like John's presentation, hot off the press, this was kind of being composed by one of my students on the drive down. So we looked at this kind of as a way. I first started, well, where are we going? We have a direction. We have industry involved. The public is involved. If we look at Google Trends, we see what the overall interest has been in biochar searches. What you see is that after the press release in 2008, there's been a constant activity. We don't see this tailing off out of the public searches. That's fascinating. This topic has remained in the public's eye as a searchable item. Now we start looking at the manuscripts for biochar. This is all the data up to the end of June. We had a big exponential growth all the way through 2013. This year, luckily, there's a slight drop in that. That's not a bad thing. This is just a resurgence that we're starting to learn more about this. There isn't everything that is new, or win. People are starting to see it is a complicated scenario. Soils are complex, and biochars are complex. When Paul was saying that he had a couple of questions, I would like to perform an experiment sometime where I send everyone ingredients for a recipe. Have everyone make it, and then we'll taste them all. Everyone will have the exact same feedstocks, the exact same temperature to heat it to, the exact times. What do you think the chances of all those foods tasting the same? This is the best analogy I can come up with for what biochar is. We can have all of these ingredient lists, all of the temperatures. We're never going to get to equal. We're going to be close as we get more and more advanced in our engineering, the new systems of the Anderson char. All of a sudden, we might be to the point where things are close, but they are never going to be identical. One of the big worries that I have is you kind of look at what our industry is. We had the IBI report of Paul showing all the industries that are sprouting up. This isn't all of them. This is just a mere spattle, the ones that had pictures on the web that I was able to find. There are over 200 companies selling biochar. I find this amazing because we don't even know what it is doing fundamentally. People often call me and say, well, should I apply this product to biochar? I said, don't know. We don't have anything to go on. And to me, it's fascinating. You walk down any supermarket aisle, look at how many brands of laundry soap you see. We don't have 200 laundry soaps. Where is the support for this market going to come from? So we look at this, and thanks, Ed, for finding this picture. Scrooge McDuck knew how the world worked. It all centers around money. Whether you want to admit it or not, it is economics that drive the entire systems. The problem with biochar is we have economic problems. Ever since we started looking at this, we have all of these reports from the early times in the 1800s when all they were doing was burning the material in the field, covering it with soil, trying to get a fertilizing improvement. We could go on and showing all the ones that had decreases. This is what, to me, is the most fascinating. In 1849, 70% of our workforce was on farms. They were 160 acres. One farmer only had to support 2 people. That was average for the entire U.S. at the time. Farmers got paid 75 cents a bushel of corn. This initially looks kind of, well, that's probably what the economics of the time were. So we look today. I got up this morning and looked at the corn price because that has been causing a lot of headaches these last 2 weeks if you haven't seen it. The current price for corn this morning, $3.71 a bushel. What this fundamentally means, farmers are only making 13% what they used to in 1849. Think of all the additional costs. They've gone from the 1 horsepower horse to the 10,000, 30,000 horsepower tractors. That is a huge economic investment. It's not just a tractor. All of the implements, the planters, the combines, all of this is packed on top of this. So the dollar in 1914, and that's the last year the Treasury goes back to because it said no one cares before that. The $1 bought $22.57. So 1 bushel of corn should be selling for $16.92 if the economics were the same. But they're not. So, what is the question we have to ask ourselves about what the future of biochar is? You have to be able to answer that question. Is biochar better than current practices? We saw a lot of presentations today going from biochar versus a control, biochar versus unburned stovers. Is that what we should be comparing to? There was a very good point that the carbon contents are different. But I would also argue the pHs are different, calcium are different, sodium are different. Where do you stop normalizing? That is a huge problem in this. The thing that I like to bring out in this little minutes, and I promise you don't have to listen to me very long, soil fertilization, we know how to do that. We have fertilizers. Until we know how biochar can improve those actions, no one is going to be coming to the table to buy biochar. Is this better than compost? You've seen studies now that show, yep, we do see changes in bacteria ratios. That's changing. We add biochar, we don't always see those. Do we want to change the bacteria? That's some of the questions. What do we want that char to do? Nutrient capture. We've seen a lot of research in that, from the posters to presentations. Do we want biochar to do that? Or is a nutrient capturing resin better, more economical? Because it's more efficient, and all of a sudden, even though biochar is cheaper, we might need 100 times that volume to capture the same amount that a resin does. Soil remediation. We have all studies looking at, well, it absorbs metals. It doesn't bioremediate. These are different terms that are almost used interchangeable. We put char in, we still have zinc. It's now on that char. How long is it going to remain there? Those are the big questions. So people have been saying, well, we have an activated carbon substitute. Do we really? Its biochar typically is unreliable. Versus an activated carbon, it has a very reliable performance. These are just things that you have to remember about moving forward, about saying biochar is going to be replacing this. You have to remember, does it really? The biggest factor is this bottom point. Biochar is lost bioenergy. By that I mean everyone's looking at the cost of biochar to be the feedstock plus processing. There's one other piece. We have to account for the difference of cost of energy. Because if we burned it in a gasifier, GTI up in near Chicago is getting near 89-90% efficiency. All of a sudden, our char has another indirect value. That is the displacement of production of energy. That has been the traditional battle between agriculture use and energy use. The other thing I like to bring out is that all is based on perceptions. This is a nice little diagram that I use to just show all this. You see the person on the right says, nope, there's 4 logs. I have a person on the left, and the person on the right says, nope, there's 3. In actuality, there's no logs. They're just lines. So it all boils down to how you look at a material. We see this pile of biochar. Things look very homogeneous. It looks like, geez, that is all the same char. We look at that under the microscope, and I challenge you to find 2 particles that are the same. Things all depend on our perspective of how we look at this material. So what is our path forward? The best summary I can put together is we have to find applications where paying for biochar replaces either an inefficient management option or improves sustainability of an option. Those are the only two things that I can see where people will be coming to the table to buy biochar.